The other thing you might want to notice is the gear. When you get your wheels, this is what you're getting. The later versions have these spoked wheels. The first ones did not. They were just solid. But it's rubber, spoked wheels. The problem I had was I fly generally off a grass field. And for a grass field, there's just not a lot of wheel there for the short grass. So what I ended up doing was buying these wheels at the local hobby shop and just put them on the existing landing gear wire. Now the instructions probably will tell you to mount the gear like this. But most people, if you look at any of the videos, will tell you that this thing has a tendency to nose over if you mount it that way because the wheels are way back here. So they reverse it and they just install the wheels like this, so the spring, they stick forward of the wing. That's what you're probably going to want to do. That way you don't have nose over tendency. So get a bigger wheel to put on your landing gear wire, mount it so it's forward. As I mentioned before, these are the holes. One for the button, the plastic round cover is still there, and here's the hole for the switch. There's nothing in there now. They're completely gone there with the brush setup system. When you buy these wheels, you can buy them at a hobby shop or you can order them online. It's very likely that the diameter of the spring is not going to match the diameter of the wheel hole. And you're probably going to have to take a drill and very carefully drill this hole to match the size of your gear strut, your spring strut. You want to make sure that you do that straight on so that you don't make an oblong hole to where your wheel is going to wobble. It's kind of a delicate work, but that's what I've done on all of mine. You just size up your spring strut with a drill bit and drill that hole bigger, and you can just put it on. The end of the spring strut is a cap. You can just pull it off and you can pull it and push it back on to hold the wheel in place. It doesn't look like it, but that's what it is. You can, and it's stock with your airplane. Pull this cap right off with some pliers, slide your wheel on and off as necessary, and slide the cap back in place. Alright guys, here's my steerable tail wheel setup. Like I said, the original stock one, the fixed tail wheel, it's just fine. I just wanted to get creative. I bought a steerable tail wheel kit. And of course, as usual, the kit you buy is really never complete good, or it's really never sufficient for the application you need. And this one came as a kind of a straight shaft to go up the vertical side of a rudder. And my setup was not such that it would line up just right. I cut the old one off right at the base. I believe I left the base on there. I just cut off the part that housing it held the wheel, and I glued this one right onto it. I ended up putting a piece of block foam to extend it up a little bit because I needed this room, because I was going to go across to the bottom of the rudder, and in order to do that I needed to drop it down a little bit from the rudder. So I put a piece of block foam, I glued it to where the old tail wheel was, and I glued this new piece, this new housing, on top of it. Like I said, the tail wheel and the shaft was a straight shaft. I didn't want to mess up my rudder setup, so what I ended up doing was I bent the shaft over 90 degrees after coming out of the housing, after putting on this collar and locking it in place. And the reason I put this collar on there and locked it in place is so the shock of landing would be absorbed in the collar. It would be taken up with the collar and not with the rudder. I don't know if that actually works or not, but that's what I did. But it is tightened down, locked on there. And I bent it over 90 degrees so it lined up along the bottom of the rudder. Now, how I held it there is simple. This is a control rod tube. It's just a simple hard plastic tube, hollow, that you would run a control rod through. And I simply split it in half to I had two half moon shaped, I split the tube in half about 1.5 inches or 1.25 inches. And I glued half of this tube over the rod and onto the base of the rudder. So the rod is just sitting inside this tube. You can use the whole tube if you wanted to. I mean, that would work fine too. But I just cut it in half and glued half of it on. So now it holds this rod to the base of the rudder. So whenever the rudder moves, it turns the shaft and turns the tail wheel. That's all I did. There was really nothing to it. Had to get a little bit creative in my engineering, but now it works great. So when I move the rudder, I don't really want to, I'll do it this way. Move the rudder, move the tail wheel. Works great. So that's all I did with that. Here is the difference in size between a stock receiver and this one here. You can see is set up for, if we get the lighting on it, might not be able to read it. It's 35 on the frequency. The one in the box is 40. This is from my old one. I flew on this receiver for 1.5 years easily, maybe even 2 years. It works fine. It's got the long snake antenna, single antenna that, like I say, tapes to the underside of the airplane. It worked fine. I eventually went with the Tactic system because of the, like I say, the batteries required for the transmitter, and I was using a Tactic for other airplanes that were 2.4 gigahertz. So I just decided to use one transmitter for everything. So I've got this. You can see the difference in size right here. So naturally, when I put this one in, I had more battery room front to back. So I didn't, it's unnecessary now to have that side of the fuselage trimmed to fit the long battery. Here is a Spectrum 4-channel receiver. That thing, compared to the stock, that one's going to give you all kinds of room in there. And all you got to do is use a Velcro to mount these in and Velcro to mount the batteries if you want to, and everything's fine. I'm going to go to this one because it gives me more space inside there for the batteries, and I'm currently using a DX8, so I want to use that on these airplanes. That's the only reason I'm going to do it. Alright, one of the things I forgot to mention is center of gravity. One of the most critical elements of an airplane once you get it all together. I haven't done my center of gravity check on this thing for years. So they've been flying so well, I've never had to check them. But I did it originally when I put the first one together and I compared it with the second one. The instructions do not give you a center of gravity location like every other RC model does. The Harbor Freight P-51 instructions is a single sheet of poster paper with pictorial diagrams of the installation on the front side. They don't even mention center of gravity, but what they do give you is the wing dimensions. And also you can measure your wing dimensions. You can trace them out and measure them and get a general volume or space, wing area. And there is a formula, and it's been several years since I've used it, but there's a formula you can find online for calculating center of gravity location on a wing just by the measurements and dimensions. And when I did that, I came out to these marks right here, and these marks measure out at the forward one is 65 millimeters from the leading edge of the wing, right where the wing comes up to the fuselage. 65 millimeters to the front line, 75 millimeters to the back line. When I calculated it out, this is kind of the window, the envelope I thought was reasonable for those calculations. This is on my original airplane, of course. And I think in the end, where I have my dots is where it turned out to be more often balanced, which is close to the 65 millimeter mark. And I think all I did on this airplane was transpose that mark over on the blue nose. So it's right about 65 there. And I try to set the plane, the blue nose, up to where it balances on that point. And that's how I did it. And they've been flying quite. Now to achieve my balance on those points, I did have to do some weight shifting. Now on a good airplane that has not had any crash damage, just pretty much a stock airplane with the new brushless system, but an unrepaired airplane, I found that I had to put, well, this one here, you have to consider the steerable tail wheel is a little bit heavier than the stock tail wheel. That throws it a little bit. But I ended up having to add some weight to the front. And what I did, I don't know if you can see, but if you look down into that air hole underneath the nose, on the back side of those wires that are at the top end of the screen, those three, the blue, red, and black wire that you see kind of snaked around, there's a bulkhead right there, vertical bulkhead going straight down. And I have 2 1/4-ounce weights stuck to the front of that bulkhead. They're kind of like sitting in there vertical, right between that top blue wire and red wire. And if I get the light right, I don't know if you can see them or not. It's hard to get on them. But there are 2 in there stuck to that bulkhead, and those 2 1/4-ounce weights, which equals of course a 1/2 ounce, are what it takes for this airplane to balance on that 65 millimeter spot. This airplane here, it's a little bit different. I actually have 1/2 of a 1/4 ounce, which makes about 1/8 of an ounce of weight taped to the back of that airplane, right behind the nose, or right behind the tail wheel. The reason I had to add weight to this one on the back side is because this airplane has been repaired so much. There's so much glue and added foam to the front of this airplane. It actually feels like, when I pick it up, it's tricky. It feels like I have a battery in there. There's so much weight to the nose just because of the repairs. So it feels significantly nose heavy. So I had to add a little bit of weight to the tail just so that it balances in my little window there with all the repairs. So that was, for me, the magic number is 65, and you can go back as far as 75 on the millimeters. And here, of course, 65. So you may have to do some lead weights to achieve that. That's just the CG as I have mine set up. I haven't heard anybody tell me one way or the other. I just calculated it out by some random formula online, and that's what I've been going by. So in conclusion, when it's all said and done, if you just do the minimum modifications, I mean just the 3 items that I mentioned, if you just change the battery, the speed controller, and the motor, and you keep everything else stock, you're looking at spending, you know, upwards to somewhere near $80 extra. So you bought an $80 airplane, and then you're going to put another $80 into it to get a brushless motor and a speed controller, and a LiPo battery. And it could be a little less. Maybe it's only about between $65 and $80 additional. I'm going to say $80 additional. And if you go further with a new receiver and go to a 2.4 gigahertz system, you're going to put a little bit more into it. But you know, $80 is not that bad. You know, a lot of people say now you have a $160 airplane for a Harbor Freight airplane, but in the end, this is really a very stout, strong, sturdy airplane. And it's probably comparable to the Park Zone. I think of all foam airplanes, this is probably the most ruggedly built. And it's not just because it's from a tool manufacturer, but I think it's just the most ruggedly built. So $80 extra to upgrade the power plant system and the functionality of it, I think it's okay. I think that's worthwhile. So I haven't complained. In fact, I've done 2 of them and I have a 3rd one in the waiting, so it's not that bad.